Radicals, if you remember, are the symbol and then whatever the root are. We wrote this in, I'm sure we wrote it in geometry because I wrote it with them already this year. You did it in Algebra 1. You did a great job of it in Algebra 1 because y'all do a good job on breaking these down. Let's do the symbol. Let's do the square root of 16. Now, I don't always put that little shelf right there, but the symbol itself, if you remember, is called the radical. So a radical is not always square root. If there's nothing here, there's a number right here on top of the shelf. Let's see how I wrote that. I've got, that's called the index. It can also be called the root if no index, it is square root. Let's go ahead and do square root, which is 4. So this number right here, under here, is called the radicand. We'll show you what I'm talking about, like if you do the cube root of 8. See, if you have a root, and I don't always put the little shelf there, but if you have a number there, if there's nothing there, it's square root. If there's a 3 there, that would be 2, because 2 times 2 times 2 is 8. You can take, like if you do square root of -4, that is no real number. We're going to actually get into the square root of negative numbers here pretty soon. No real, say, number. There is no answer, we'll say, for square root of -4 in our real number system. The cube root of -8 is -2, because -2 times -2 times -2 is -8. You can actually take cube root of negative numbers. You can take any root, and that's a 3. Didn't necessarily look like it from up here. But anyway, you can take cube root of negative numbers. You can't take square root of negative numbers in our real number system. We have to introduce a new system. Let's start with, I'm not going through all of those numbers. Let's start with square root of 20. If you remember what we did, we're looking for perfect squares like 4 and 16 and 25 and 36, those type of numbers. You remember what we would do is the factor tree with prime numbers. I didn't think I'd have to do all the steps again. I think it'll refresh, come back to you. So the square root of 20 is the square root of 2 squared times 5. Now if I'm reviewing stuff you don't remember, be sure and let me know. I will put this extra step in. I don't put it in every one of them. We're going to actually separate those. You can put multiplication together. You can actually split it back apart. This is a rational number. The square root of 2 squared, which is the square root of 4, is 2. And the 5 is an irrational number. That just simply means it's like pi. It never ends. It never repeats. And you type it on your calculator, you're not going to see a pattern to it. And we're trying to get the rational part outside. That is multiplication, 2 times the square root of 5. If you have a number out front, like 4 square root of 60, okay, we'll do the square root, coming back. And then I get to here, 2 won't go. Remember, your prime numbers only have 2 factors. So you're using 2, 3, 5, 7, 11. 2 won't go, but 3 will. When the bottom one is prime, a number that only has the 2 factors, 1 times 5, then that's your factor tree. So I'm going to leave the 4 out front. I'm going to put the 2 squared inside. And you can rearrange these any way you want to. I leave the 3 inside and the 5 inside. This has to multiply to 60. You know, 4 times 3 times 5 is 60. The 4 is going to stay out. This is a perfect square. When I taught in Algebra 1, probably last year, we talked about taking that out. The square root of that 4 is 2. And then the 3 and 5 stay inside. That is an irrational number, broken down as far as you can. There's no perfect square. Like 15 is 3 times 5. There's no 2 3s, there's no 2 5s, so we get 8 square root of 15. Is the rational part, and it probably at this level, I always just talked about the inside outsides with you last year. That's going to be important, and then this is irrational. Rational numbers are the part that it's any number that you can make it a fraction. Its decimal ends or repeats. 8 is just 8 over 1. It's just 8, you know. And square root of 15 is that irrational part. It's never going to, if you type it on your calculator, It's never going to end. It's never going to repeat. It's irrational. It's that split down the middle of the real numbers. Just a refresher from geometry and from Algebra 1. Remember that the square root, we kind of used it up here. The square root of 5 squared is the square root of 25, which is just 5. The square root of 51 squared is going to be 51. You don't have to, and that's important for the ACT, that you don't have to take that time to square it and then take its square root. So adding to that, the square root of x squared is going to be x. So we need to talk about perfect squares with variables. Well, it's pretty easy. Even though x squared is a perfect square, x to the fourth is a perfect square, we're going to treat them in pairs. So we're really just looking for x squared. That's really the only one you have to know. X to the fourth is, x to the 6 is, x to the 8, ... That can come up in the difference of two squares. So that is important in a little bit step up from regular Algebra 2, but just to recognize that. Let's start with one like number 3. Let's do the square root of x cubed. You'll like these because the factor trees are so easy. You don't have to do birthday cake or upside down birthday cake. What is the factor tree of x cubed? X times x times x. Okay. Now remember, we're looking for perfect squares, and you probably are going to skip that step in just a moment, but I'm going to write that as x squared and with my little x left over, because this part you can take the square root of, this part you can't. It doesn't have a pair. Remember, we're looking for pairs, and so the square root of x squared is x. So we're just going to do it like that. The square root of this one comes out. You need to separate that. X squared times the square root of x. And so you've got the square root of x squared is x, and the square root of x is the square root of x. Let's do the square root of 48 m to the 5th. Okay, now watch how I'm going to do this. Let's get our 48 like we normally do. I'm going to do it over here. 2 into 48. It's lots of 2's. You see it? 2 goes 24 times, 2 goes 12 times, 2 goes 6 times, and then 2 goes 3 times. So I've got 2 squared times 2 squared times 3. Do you agree that m to the 5th would be m to the 2nd times m to the 2nd times m? Now, why would I want to break it like that? Because it's, again, just like doing the factor tree of my 48. I have 5 m's. I pair them up, so I have an m squared, and a leftover m. Now, I will show you if you want to approach, and look what I'm doing. I'm circling the ones that are going to come out. Say that's a perfect square, that's a perfect square, that's a perfect square, that's a perfect square. So, and I've got a 1 understood out front. So I've got my 1 out front. The square root of that one's going to come out as 2. The square root of that one's going to come out as 2. We'll ignore the 3 right now. The square root of m squared is going to be m. The square root of m squared is going to be m. Now what's left inside? 3m. Now what's on the outside? 4m squared times the square root of 3m. Or you could have said the square root of, I'm going to do the 48 the same way. 2 squared times, I'm going to underline my or. 2 squared times 2 squared times 3. Now watch what I'm going to do. I'm going to put m to the 4th times m. So you've got perfect square, and if you have an odd number of variables, if you take it down one, like m to the 5th is going to become m to the 4th times m. If you put those together. Now that's important if you were to have some big exponents. So in this case, I've got 2's going to come out, 2's going to come out. The square root of m to the 4th is going to be m squared. Because remember, m to the 4th is m squared times m squared. The square root of m to the 4th is m squared. Let's write that up here. The square root of x to the 4th is x squared. The square root of x to the 6th is x to the 3rd. You see the pattern? You're just dividing by 2. See, when you multiply x squared times x squared, you're adding the exponents together. 3 plus 3 is 6. And so then you can just divide it by 2, cut it in half, and that will give it square root. And then you have the 3m left inside. It gives you the same result. Let's do one more of these, and then I may do one with a little bit bigger numbers in it.